This time, let's go over a LeetCode medium question called Predict the Winner. In this problem, you are given a list of integers, and two players are picking an integer from either side of a list at a time as the score for the round. Your task is to figure out if the first player will have the maximum accumulated score at the end. As to the constraints, there are at most 20 numbers in the array, and range of each number is within 10 to the 7th. To solve this question, a very intuitive solution to me is to use dynamic programming. If you are given an array here, starting from L to R, I want to know what the maximum value I can get here minus my opponent's value. I want to call this dpLR. If this value is larger or equals to 0, it means that I win. Otherwise, my opponent wins. To calculate this value, I can break it down into two subtasks. I can either pick the number from the left, and now the rest of the problem become the subproblem for my opponent to solve. Or I can pick up the number from the right, and then the rest of the problem becomes the subproblem for my opponent to solve. In other words, I will have a subproblem of L plus 1 to R, or L to R minus 1. And the score I got here is L minus dp L plus 1 R. The other side will be R minus dp L R minus 1. I will try to find the maximum value of these. That's the optimal decision I can make here. And I will keep it as a result for dp L R. Now let's think about the complexity. How many states do we have here? Once I know the value L and R, then I can uniquely identify this status. In terms of status, I have L times R combinations, which also means n squared combinations. How about transition? I only have two options here, either picking the left one or the right one. This is two transitions, or O1. These will result in O n squared complexity. And this is the complexity for this algorithm. If I have a function called dp, which takes L and R as inputs, I might have some corner cases I need to deal with. Actually, there's only one corner case here, which is when L equals to R, then I'll just get that value and return. There's no more subtask I need to do. After that, we'll need to do a memorization check. If this LR status has been visited before, then I can just return from here directly. I already remember that result. I don't need to dig deeper into it. After that, it's a transition block. As I said, the maximum value we want to get here is between L minus dp L plus 1 R and R minus dp L R minus 1. And this is the result we want to return. Afterwards, we will need to update the memorization. And then at the end, return the results. So this is the pseudocode for this problem. Now let's jump into the coding part. I'll start with introducing some variables. Self.nums equals to nums. Self.n equals to length of nums. I also need to keep a record variable to keep track of whether an LR pair has been visited before or not. By default, I will say it's none for underscore in range self.n. This is the left boundary. I also need to have an outer loop for the right boundary. After initializing these variables, I can finally make a code to this dp function by passing the L boundary, which is 0, and also the R boundary, which is self.n minus 1. So this dp function can tell us how much more score I can get against our opponent. In other words, if this value is larger than 0, it means that I will win the game. Otherwise, I will lose the game. This is the result I want to return at the end. Now, what's the dp function look like? First of all, we will have an L boundary, which is an integer. Also have an R boundary, which is also an integer. And this will also return an integer as the extra score I can get against my opponent. We will start with having a corner case check. If L equals R, then there's no more subtask I need to do. I can just return self.nums L. How about the memorization check? If self.rtd L R is not none, it means that at some time point we already updated this value. So we should just return self.record L R. If none of these above conditions got triggered, then I really need to figure out whether I should pick the value from the left or from the right. And the way I figure this out is basically by enumerating all the possibilities. In this case, maximum value will come from two options. Either I pick the value from the left, I will actually get self.nums L. At the same time, my opponent will also try to get the maximum value out of his or her hands. And that value will be self.dp L plus 1 R. The other option is now I pick the value from the right. And correspondingly, and the maximum value my opponent can get is self.dp L R minus 1. And once I get this value, I will basically memorize this self.record L R equals to max speed, return max speed. Now let's try if it works. Okay, you passed 2 cases. Now let's do summation. Cool. It beats around 70% of the users. And yeah, that's the end of this video. Thank you for watching.